Welcome to Superhero Simulation. As promised from last week, we're going to be checking out a thermal stress analysis of Mr. Freeze based off of the heat transfer analysis we did last week. We're going to be using Autodesk Simulation Mechanical and of course the results from Autodesk CFD. If you want to check out the video from last week to catch up, click the little link there on your screen. Again, as always, feel free to reach out to me at james.herzing@autodesk.com. Follow me on Twitter at Mr. Simulation Rocks, or follow me at ADSK Simulation. So remember our Autodesk CFD analysis from last week. We had Mr. Freeze standing there, and we had to turn him into a 3D CAD model, so we used Fusion 360 to piece part of him together. And of course we then ran our heat transfer analysis, where we can see the nice cold head and then the 70-degree warm air around the body. So what are the assumptions we're going to have to make about Mr. Freeze this time? Thermal results from Autodesk CFD are going to be used. We're going to apply fixed boundary conditions on his legs, so maybe we'll just assume he's encased in ice. Maybe his freeze gun backfired on him. And of course he still has a super sweet pet polar bear that none of you told me why he has it to begin with. And those are our material properties we're going to try and apply to simulation and sim mechanical this week. Alright, so here we are in Simulation Mechanical. If we go ahead and click Open, we can browse to all file types and open the same IGES file that we used in Autodesk CFD. We're going to choose to import that as a solid model, and then choose Static Stress with Linear Material Models for our analysis type, and click OK. We're going to go through a couple of options that I should really turn off for the next video, and here we have Mr. Freeze imported as all sorts of different colors. We're going to start out by generating a mesh. We can quickly mesh all of the parts. Whoever created this model obviously was designing it for simulation because it meshed so nicely. And now we're going to go ahead and apply all of those material properties that we talked about earlier. So we're going to make them match up like we did in the CFD analysis, and this is the longest part of the whole setup. So the first part, we're going to go ahead and make it A36 steel. I always use A36 in Sim Mechanical. Old faithful, all of the material properties are there. Next, for part 2, let's go ahead and make this glass and choose one of those 3 selections. And now the body part, we're going to be able to make titanium and the arms aluminum. So I believe parts 4 and 5 are the arms, so we can make those aluminum. Same process over and over. And again, you can see all of the properties are there, especially the thermal coefficient of expansion, which is what we're most interested in for this analysis. And now the rest of it, we're going to choose titanium and click OK. So now all we have to do is apply our boundary conditions and our loads from CFD. So let's start off by getting the model in some sort of view we can use and grab where those legs are, and we're going to say that, again, his legs are encased in ice because he doesn't know how to use his freeze ray, and we're going to add some fixed boundary conditions there. So under Setup, click the General Constraints button, click Fixed, and there we have it. And the last thing we need to do is choose the CFD results. So if we choose temperature, it's going to automatically open the analysis parameters for us. And for our source of temperature, we just choose Autodesk CFD file and browse to the .cfdst file. Very nice, dot at the end of that. And lastly, make sure we put our multiplier to 1 for thermal. So we're going to be turning on thermal loads by doing that. And click OK. And when we do so, we're now ready to analyze our model. So if we go up to the top ribbon, we can click on Analysis and Solve, and off we will go to view the results. And here we have it. There's the displacement of our model. Down at the bottom, of course, there is no displacement. And then up at the arms, that's where the highest displacement looks to be. Seems to make pretty good sense to me, but let's look at the stress. So here again we have it. Since our legs are completely locked in place and yet they're still expanding, or I guess contracting in this case, we can see higher stress there. But what I think we would be most interested in is the stress around the neck piece and glass helmet. So let's go ahead and go into the legend properties and get a better idea of what we're looking at throughout the whole body. We'll set our low value to 0 and our high to 10,000. Click apply, and now we can see a much better scale. And so, of course, as expected, the highest stress is in that neck area. So just like for a normal guy, maybe you want to punch Mr. Freeze in the throat to bring him down, and that's his weakest area.